Hi everyone, we're going to graph y equals 2 to the x, an exponential function, parent function. And the reason these are important is because you have to know how to graph these before you can do logs and LOGs and LNs and things like that. So we're going to graph it and do a table of values. We're going to discuss these two, where's y positive, and these two, we're going to talk about end behavior of the graph. And also, we're going to talk about symmetry goes with this even or odd function or neither. All right. And then we're going to fill out the rest of this. So you might want to write all this down. The first thing I'm going to do here is do a table of values on this. And I'm going to pick -2, -1, 0, 2. So when I plug this in, 2y equals 2 to the -2, that equals 1/4. All right, because that's 1 over 2 squared, so that's 1/4. -1 is going to be 1/2. 0 goes to 1. Anything to the 0 power, 2 to the 0 equals 1. Anything to the 0 equals 1. And then 2 is going to go to 4. Well, why did I do that? So 1, let me put 1. 1's going to go to 2, and then 2's going to go to 4. It maps to 4. So I went ahead and graphed it over here, and basically this is what it looks like. All right, something like that. All right, so the domain is all real numbers. We can plug in any numbers here. So the domain is all real numbers. The range, however, is y is greater than 0. It will never have a 0 here. In fact, we have a horizontal asymptote here at y equals 0. That's your horizontal asymptote. All right, in case you need to know that. All right, next we need to discuss where's y positive. Y, from here, y is positive in quadrant 1 here. So when y is positive, when x, the interval that it's positive, when you're talking about the interval, you're talking about 0 to infinity, because we're going to infinity here. All right? Y is also positive here, because that's in quadrant 2. So it's also positive from -infinity to 0. When we talk about end behavior, we're talking about what's happening right here with where this is continuing on. And the way you discuss it, you're going to say, as y, that's your y, approaches infinity, x approaches infinity, or x gets larger and larger. Also, as y goes down here, so it's going down. So as f of x approaches -infinity, y, your x is going to -infinity. All right? So basically, that's how you would do it. This is as x is getting, as y is getting smaller and smaller. That's what this means here. As y is getting smaller, your x is getting smaller. Okay, so there's no symmetry here. So no symmetry is none. Therefore, it's neither even or odd. The function is 1-to-1 because it passes the horizontal line test. Therefore, we don't have to restrict the domain. There is no zeros. So when it's talking about the zeros, there is none because it doesn't cross the x-axis on this one. All right. So now we have to find out what the inverse function is. And what I'm going to do is just do my table of values here. We had negative 2 was 1/4, and negative 1 was 1/2. 0 went to 1, 1 went to 2, and 2 maps to 4. So that's your original. And what we do for the inverse is switch the x and the y. So 1/4 is going to map to negative 2. 1/2 is going to map to negative 1. 1's going to map to 0. 2's going to map to 1. And 4 is going to map to 2. So I'm going to go to 1/4 here on the x. That goes to negative 2. 1/2 goes to negative 1. 1 goes to 0. 2 maps to 1. And 4 maps to 2. All right, so here's where it is. All right. So it kind of tapers off here. Now basically this is log base 2 of y equals x. Okay, that's your log function. And it's the inverse of y equals 2 to the x. And again, y equals 2 to the x was here. And it's something like this. I'm just going to kind of graph it here. And I can't draw very well. All math teachers say that, right? Okay, so it reflects over the y equals x. All right? So that's your inverse. And then we got to do transformations. So we're going to write this as y equals 2 to the x minus h plus k. So this is your horizontal. You can put that in parentheses if you want. This is your horizontal part. It won't do it for me. Okay, that's your horizontal part. This is your vertical part. So basically, let me go ahead and draw the parent function again. 1 goes 2 goes to 4, and 1 goes to 2, and 2 goes to 4. So it's something like this. Now all I'm going to do is let's go ahead and shift this to the right by 2. So all I'm going to do is move these points over by 2. So it's still the same thing here. It shifts to the right by 2. And then for that's a horizontal shift. And for the vertical shift, we're just going to write, let's go down by 3. So why did I put plus? So minus 3. So I'm going to take my parent function, and which is the purple one, and I'm going to go down 3. So from here, going down 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So basically you're changing the horizontal asymptote to y equals negative 3. Because before it was y equals 0, so basically you're drawing the same thing, but it just got shifted. Okay, something like that. Actually, it should go up more. All right. So that is the vertical shift down by 3, and that means your horizontal asymptote changed, and that means your range changed. So your range would be y is greater than negative 3 for your domain. Okay, that's all of this one, and the next one I'm going to do is y equals 1/2 of x. Thank you and have a nice day. Bye-bye.